Okay, all set then. So thanks for that intro. I have two things to demonstrate. One is the genome browser and the other is the RESTful API. So kicking off with the genome browser. In the CTMM trade project, which provided the funding for this development, we worked together with our partners via Universiteit Amsterdam, Philips Research, the Netherlands Cancer Institute and the Erasmus MC in Rotterdam to work on the visualization of genomic data in tranSMART. The use cases that we had are basically we wanted to be able to compare genomic variants between different patient cohorts, so based on the clinical information that we have in tranSMART as well. We also wanted to compare genomic variants as well as copy number variation data with public information like encode tracks, cosmic variations, etc. So technically what we did in terms of requirements is we were looking for something that would fit right into the GUI of tranSMART. So we wanted an HTML5 genome browser. We wanted to be able to drag and drop high-dimensional nodes from the tree structure that you've seen multiple times in this the early presentations into the browser and then basically visualize the data behind that. In writing this code and adding this feature to tranSMART, we tried to leverage also other open source developments, and we found two components that fit well. One is the Dalliance genome browser that was developed by Thomas Don in Wellcome Trusted Sanger. And the other component is MIDAS, which is mainly developed by the European Bioinformatics Institute. Both of those solutions we implemented in tranSMART as a plugin, and we also extended the core API. I'll come back to that in a moment when I demo the RESTful API. So this resulted in two different plugins which are bundled in the 1.2 release of tranSMART. One is, as you can see, the front end showing the browser. I will demo it in a second. The other part is a backend that basically serves out genomic track data as you go. So when you browse in the screen of Dalliance, it will in the background issue a request for the track information that's being shown and a particular window that you're looking at, and it will then do that via the DAS protocol, and the MIDAS plugin will transfer that information back directly to your browser. All right, so let me just show you this now live. Sorry, just a moment. Make sure that they have the resolution right there. Yes, so first of all, I have a study here with some cell line data. This was also provided by partners in the CTMM trade project. And within that study, I do have biomarker data, DNA-seq, as well as copy number variations. So basically, this is array CGH, and I have that for 10 different cell lines. So what I can do now is fire up the genome browser and then drag this particular high-dimensional data node into the browser, and that will bring up the tracks that are associated with that data. In this case, the gains and losses. Unfortunately, I'm too much zoomed in right now to see any differences. The genomic region is not long enough. If I would zoom out here, you would see the differences of the copy number in the regions. The other type of information I can show in the genome browser is actual genomic variants. That can be SNPs, which are represented by the plus signals that you see here. They can also be unidentified mutations like this one, which is hard to classify and is hence labeled as diverse. And of course I have the classical insertions, deletions. So I have the green symbols here that mark an insertion and the red ones that mark deletion of nucleotide. or a series of nucleotides. What you also can see here is the allele frequency as well as the minor allele frequency. The nice thing about that is that you can see the frequency both of the predominant as well as the minor allele, giving you background information on the cohort that you selected. In this case I only have 2 patients, so it's not particularly spectacular, but I guess you get the idea. You can also put any other information like quality of the reads or custom labels, and as long as you provide that in a VCF format, import that in tranSMART, you can show it here. So one thing that this allows me to do is compare the, for example, the frequency of the minor allele frequency in the cohort that I chose versus the minor allele frequency in the study as a whole. Navigating in a genome browser, that I can do with zooming in or out. I can also scroll. And of course go to a particular genomic location or gene. Going to a gene is done by typing in the gene name in the search box on top. So if we get, for example, the tumor suppressor gene 53, I can see here the mutations that I have on my cohort in that particular gene. All right, that's the demo of the genome browser. I guess if there's no questions or comments, then I'll just go straight into the RESTful API.
Please do.
Okay, so the RESTful API. And maybe to get some context for this, the RESTful API, one of the reasons why we developed this is to be able to hook up outside tools, for example, enterprise visualizations tools or other toolkits that you want to use to visualize or analyze data which is inside tranSMART. If tranSMART wants to become the leading translational research platform, then I think it needs a few things. So it needs a sound architecture, it needs options for enterprise integration, like I said, and also connect downstream analysis tools. So the RESTful API, and I'll just also briefly touch the other APIs that we have, was built and developed recently. Actually, I gave the same demo in April at a community meeting, so for those people that were there, my apologies. It hasn't changed much. But this RESTful API was developed, funded by Janssen, as part of the eTrix program. So I promise you to go into the APIs of tranSMART. The first one is the tranSMART Core API. This is the innermost API in tranSMART. It's in Groovy, and it describes the language in which the various plugins or components of tranSMART talk to each other. The Core DB is a reference implementation that is currently suited for Oracle and Postgres, but you can easily adapt it for any other databases like MS SQL Server if you wanted to, because it uses Hibernate. Both of them come bundled with tranSMART 1.2, and so does the RESTful API. Now, the nice feature of the RESTful API is that it's basically completely independent from all the architecture and structure of tranSMART itself. So if you have an outside application that you want to use to, for example, develop a visualization tool on top of tranSMART, or hook up a tool like Spotfire, the RESTful API is the easiest way to go. So how does that work exactly? It exposes low and high dimensional data over HTTP protocol, and uses OAuth2 for authentication. This is the same protocol that modern web APIs like those of Twitter and Facebook use. For high-dimensional data, we use a compression protocol and buffering protocol called protobuf, which is the same one that Google uses for their data-intensive APIs. And like I said, this now allows you to build a client, for example, for R or Spotfire. The Spotfire client is being sold by PerkinElmer. The R client, I want to show you that briefly. This is an open source library, so you can look at the code. Luckily, R has already packages for dealing with RESTful APIs as well as dealing with the protobuf and OAuth protocols. So the code is not too complex. But what it provides you as an R user is a nice and easy interface on top of the RESTful API, which you can just directly use in R. So here, I have R running on my laptop. And the first thing, if I want to use data from tranSMART, is I need to authenticate myself. So after installing or pointing R to the tranSMART library, I then run the command connect to tranSMART to make sure that I get a URL which I can use to authenticate this particular session in tranSMART. I copy paste that URL in my browser, and then I log in my browser and I get a code back that I can paste back in R. So the rationale behind this OAuth protocol is that I don't have to store my username and password in plain text, nor do I have to send it in plain text to some web server. My authentication information stays in the server, and the only thing that goes over the line here is the token. Okay, so when I paste a token and it is verified by the server, I have a successful connection, and I can now get to I can now start to get my studies and the data inside the studies. Issuing the command get studies gives me a list of all the studies that I have access to under the username that I logged into, in this case admin. So going back to tranSMART, let me first show you the study as we have it. It's a GeoStudy with some clinical data and also mRNA data. I think it's an asthma study, and one of the things I can do now is get my subjects. Get subjects gives me a table with the respective subjects in the study, as well as all the clinical information that I have on them. So next I can also get the actual data, low-dimensional data. In this case, the forced expiratory volume ratio. So now I basically take only one column of this data, and I can then use that, for example, to make a box plot of the FAV of males versus females, as you can see here. I have the same types of commands to get any high-dimensional data out of tranSMART. So in this example, I have in my study a mRNA data set called lung, which is an Affymetrix microarray. I have limited the number of probes in the data to 55 to be able to show you this in real time, although it's a recording, of course. Normally this would take a little bit longer. So now what I get back if I issue this command get high-dim data is the microarray data, specifically the log intensity. As you can see here, I specify with projection the specific parameter that I want to get from R. I could also, for example, obtain the Z-score or the roll intensities, whichever I want to use. And then once I get that data back, which is basically just an array with the, a matrix with the probes versus the patients or samples, I can then do things like draw a heat map with hierarchical clustering on both axes. So I have the probes here on the bottom and my patients on the right, as you can see. Okay, so that concludes the demo of the R interface. I hope this highlights how the RESTful APIs allows you to build your own tools on top of tranSMART. And I do hope that we will see a surge of new plugins in the coming months, years. Now that more and more organizations adopt tranSMART as a data warehouse, we can actually leverage developers to build new things on top of it. So that concludes my demonstrations. Thank you.